This tutorial will illustrate some of the selected modeling options available in PX Perform Extension, which is an XTEND and post-processing software for Perform 2D. For modeling phase, it contains a lot of options provided for the user. Normally, when we have Perform model with the geometry that we create, we need to start the material property. And then you can follow by define beam, column, shear wall section, and other nonlinearity property. You also can define general assignments such as math, section cut, dip, and other. At the end, the user need to assign the load to the structure. So now we will move to the first item, that is the material property, which confined concrete elastic 1D concrete material. To use this one, you can go to Help, User Manual. In User Manual, just move to the section of what you want to work for. This is a confined concrete elastic 1D concrete material. They will contain a section of what the program will do and how to use the program step by step. To use this task, you need the input information, input file. So to get that file, you can go to input file here that contain two main folders. First is a modeling phase, second is a evaluation phase. For modeling phase, after you click, you will see the input file sample. Before you use this input file sample, it will be good idea that you just copy this folder to paste with the new folder and then start to use from those folders to keep the original. So now we move to the first item, that is material concrete confined calculation. After you click here, this is a sample of the material property. They have 5 strengths that I provide here with a different name and different detail. The concrete modeling will be based on the Lavis confined concrete model. After you prepare this one, copy the path or bow to find the path. Click at the confined concrete elastic 1D concrete material and run. There are only 3 steps that we need to do. After finish, it will generate concrete state relationship for 5 material. Back to see here, for the original file, at the first time it will have only one sheet, then PX will generate the other sheet for the stress-strain curve, depend on how many material that you define. Now it generates 5 material here, and it also provide you the information here that for each cell they will contain of the formulation that you can track back how the PX calculate those parameters. This is stress-strain curve plot. The left one will be used for perform. The back one will be unconfined. The blue one will be confined. So after we know the stress-strain curve, we can move to see the elastic concrete binary. In this Excel file, it will be parameter that will later convert to be binary file. You can also change the value in here if you want to change. This value take from the first calculation file, but you still be able to change the value in here. After we get here, it's time to convert this file to be binary file. You click concrete binary lighting at the same part. It will generate binary file here. What binary file look like? You can see this is the binary file look like. Then it's time to assign this one to perform. You can go to material in Elastic 1D concrete material. In here they have original 3 material that already defined for this model. I will import for the another file that created by PX. Click import. Go to see the part that you create the file. This is a binary file from PX that is generated. After you click, have file material. And then this one is a modeling parameter from PX that it automatically generates for you. You can change the value also before convert to be binary file. You can imagine if you have a lot of material property. If you use PX, it will help you to do faster modeling rather than to do one by one. For rebar, it will use the same concept as the concrete. So I will move to the next task, that is beam section. For beam section, we need to find the input file also, sample of input file. Go to the beam section. This is the format of the input file for beam section. You need to provide the information in the cell with the white color. For the green color, no need to touch because this one contains the formulation. For this one, you can get from the drawing. You know the name, the shape will be rectangular, the size of the beam, and then you also can modify form for the section stiffness modification, elastic modulus, Poisson ratio, and shear modulus. In here we have the 77 section that will be converted to be binary file for perform. After you prepare this one, it's time to convert to be binary file. You copy the part, select beam RC section, binary writing, run. The program will generate binary file here. It's time to assign to perform 3D. Go to code section, beam reinforced concrete section. In here they have the original section that already defined. Anyway, we will try to import the new one from PX. Go to find the binary file that we already create from PX. Beam section. And select all section that you want to import. Then now you can see the section already import to perform 2D. You can imagine if you have 100 section in your building, it will be really fast if you use PX by edit the Excel, change the value, and then import rather than create those sections one by one. That it might take very long time and it is a tedious work for the user. For the next, I will show you for the moment hinge calculation beam also in here. So to do this one, you might move to see the user manual again. Moment hinge calculation beam SCE. you need to provide input information because it will need those information to interpolate to find the modeling parameter and acceptance criteria. They have the step how to use this option. So I will go to beam moment hint. For the beam moment hint calculation, you can double click to see the Excel file preparation. They have 5 sections of beam. You need to provide for the beam section, material property, longitudinal reinforcement, stirrup. These parameters will convert to be the modeling parameter. After you finish, prepare this one, do the same thing. Provide the part here. Choose the option that you want to use. Click Run. After that, PX will create text file and moment hint binary. For text file, they have the value. You can copy this one and go to the initial file here, paste the information in here. So you can track back how PX calculate the modeling parameter for each beam. For one beam, they will have 2 moment hint for both ends. If you go to C, moment hint binary, we have 5 sections. It will have 10 moment hint property that it will be created. This is the modeling parameter that it will convert to be binary file for perform. If you see perform 2D, for moment hint rotation, this is a sample in the model. This is the all parameter that we show in here. So it's time to convert to be binary file after we get this file. Moment hint binary. It's time to write to be binary file. After that, perform will create the binary file for moment hint here. You can go to moment hint rotation type, import this file. The sequence will be the same with the other task also. They have a 10 section of moment hint. Select all. Now, the new moment hint type is already generated in here. You can see the graph also. If you have 100 moment hint that need to assign to your building, this is a faster way to do by using PX, rather than you create one by one in Perform. For the next task that I would like to show, that is inelastic section for column, or we can call column fiber. To use this one, you can go to the column inelastic fiber section and see the input file what we have to prepare. They have 5 column and section in here: material property, vertical reinforcement, stirrup in direction to direction T, and other property. Have some picture that provide how to count the bar. After you prepare this one, this file, you select the part here. Select inelastic fiber section calculation and run. Program will generate column fiber binary Excel file. When you click to see, they have 5 sections. This is the first section. This is a modeling parameter that will be converted to be binary file for import. importing for Perform 2D. It will automatically generate fiber for both concrete and steel. You don't need to create one by one. After you get this one, it's time to convert to be the binary file. Again, I just want to back to see for this section. Column inelastic fiber section. This is the original one. When you prepare the input file, later on it automatically divide fiber for you and define like this picture. Now it's time to convert those information to be binary file. You can click here and run. Writing the binary. Then you get this file, the binary file. It looks like this one. Time to import to Perform 2D. We go to cross section, column inelastic fiber section. In here they have the original fiber section that model in Perform 2D for this model. But anyway, I will add another file section in here. Import. Go to that folder for column inelastic fiber section. And then choose the binary file. Select all, read, click OK. Now you can see the new one here. It already provides you all information. You don't need to assign one by one. Normally, if you have to start the first section for column fiber, you need to do one by one, assign for the each fiber section. But now, PX already automatically generate the fiber for you. You don't need to do anything. Just check the result. The next task that I would like to show you is compound. After you make beam section, column section, this is a frame section actually. You make moment hint fiber for column already. It's time to combine them to be compound component. For compound component, you can use this option and this option. I will show you here. To prepare the input file is a frame compound binary. You double click here. If we don't clear how to define this parameter, you can back to see the user manual on this one. Beam compound binary. For one beam, it can be end zone for both sides. It can have moment hint, shear hint, and beam section. They can have many types. It depends on what you want to combine to be the compound. So basically, I divide to be node I, node J. For both sides, I and J, and the middle zone will be here. So this one will be the node I information, middle, and node J will be here. Node I will start with the end zone, release moment, moment hint, beam section. If you have shear hint, you can provide at the middle, and other for the node J. For column, you can use the pattern of the name CL. For beam, it will be BM here. After you prepare this one, just copy the path here and click beam compound binary lighting. After that, you will get the binary file here. It's time to import to perform 2D. Go to frame. In this model, they already have the compound that assigned for this model. So anyway, we will import a new one. The same way. Go to beam compound. Select the binary file that is created by PX. This is the new compound component that we would like to import. Select all and read. Now, all compound that created by PX is already assigned in here. As you see all steps, if you prepare the input file correctly, you can use to prepare a lot of sections and use the way import, export, something like this. It will make your work finish faster than define one by one in Perform. Next, I will move to shear wall. To shear wall also, normally we need to model the fiber section. We will start with the inelastic fiber section calculation. This is a format. They have two options, fixed size option and auto size option. You need to provide for the concrete fiber. You need to provide for the rebar fiber. Also, to do this one again, you can back to see for the user manual. This is a section of shear wall inelastic fiber section. This is the real or actual shear wall with the reinforcement and concrete. It's subdivided to be concrete fiber and steel fiber. You can provide according to the format here. After we provide the input information, time to use the program. Click inelastic fiber section calculation here. Provide the path and click run. This one, because we choose this one also, so program basically will ask you to do only one task because they will have the different folder, so they cannot find. Just select only one task. Don't be worried. Choose only one task here. Click run. Click OK. So we can see the PX will generate shear wall fiber binary. This one will be import to perform 2D. You can change the parameter in here also if you want to change. It's time to convert to be binary file before import to perform 2D. You can go to cross section, shear wall in elastic section. In the model, they already have the fiber section here. This is the original from the model. So time to import the section that generated by PX. Go to file, the binary file that create from PX shear wall inelastic fiber section. This is the all information that created by PX. Select all. Okay. Then we check. Now it come here already. If you need to define one by one, basically you need to define section one by one. That it will take time for you. By using this program, it will be faster to define the fiber section. Like this one. After that, you also can convert or combine to be the compound for shear wall also. After you get the section, you need to combine the section to be the compound of shear wall by provide the vertical axial bending property, horizontal axial bending, and shear according to compound in shear wall. So to do this one, copy the part here and click to write the binary here. PX will generate the binary file for compound of shear wall. It's time to assign compound for shear wall after we convert. In this model again, they have the original one here. This is the parameter that you provide for the original one model. Now it's time to import the new one. Input file. Move to shear wall compound. Select the compound of the shear wall that created by PX. Read. See the result. Now it already imported to perform. Okay, so now we move to the other general assignment. We start with math. To use math or this option, we need to change the part to find the model part. This is the model part, model folder. I just copy the part here, paste in here. Click math here, done. It will show you this dialog box. So I just want to rename something. Before using this one, I want to show you the original math that I assigned in this model. They will have only two math that defined in this model. This is the first one, second one. Save the model first. So now we will create another one. I will use math PX. Try to import the math. Basically, we need to know the point that we would like to assign the math to that point. The coordinate here and math for the 6-degree freedom. For example, if I know this point math then read the information from the Excel. The program will upload the information from Excel. It might take a bit time, depend on the number of nodes that you have. It's already done. They are show the number of nodes that you define also and the number of nodes that assign as well. So click OK here. Now it's time to check in the model. You need to reopen the model because they modify like the new math to the perform 3D file. Now you cannot see, just reopen. And check at the math. Now PX already come. Math from PX. So if you don't have any math, you can use this option to assign the math also. Section cut also, I will move to the section cut define. The original model, they already have the section cut. Firstly, I would like to delete all this one. This one is the original one for this model. I want to delete all of this section cut first by using this option. Go to the structure section and delete. See the model again. Now still here, just reopen first. You can see section cut is gone already. It's time to define the new thing, new section cut in the model. You can imagine if you don't design anything at the first time, you can use this option to help you, because to define the section cut it also takes time. You may have the section cut for the story, for core wall, for each leg along the height. It will take very long time to define. So this option will help you. I click and OK. Now it defined already. Let's back to check again. Just reopen the model. Now you can see the section cut already come. This is a form PX that generates the section cut for you. For the next task, you can use for the soil spring measure in fill wall also. I just want to show the dialog box in here. For the soil spring calculation linear elastic bar will look like this one. You can see from the user manual how to use this one. And in fill wall, it looks like this one. You can also include the opening as well. This one uses the inelastic panel diagonal start model. And at the last one, it will be load pattern. For the load pattern, you can define for the nodal load. The dialog box will be like this. Or if you want for the cell weight, it will look like this one. If you just leave the progress bar at least 100 but it not assign anything. The one that I would like to show you that is a element load. Back to see the load that assign in perform first. The element load in perform original, they have T load case. I will go to the last one and go to this element group equivalent slab beam. In this model, as you see, they have two main subgroup with a uniform load. I would like to change the value in here, modify the value, or modify the pattern of the uniform load in here. By using PX, you click PX, it will load the information exactly same that provide in perform. I will go to the last one for this case and select for the equivalent slab beam. As you see, it will be the same value that show in perform 3D. For the first subgroup one, I would like to change the value inside. If you want to recalculate something, they have the option of tributary area load. In this option, you can choose 4 options in here. This is the main beam here that will calculate the load, that highlight in blue color. You can use for the two-way slab with 1 secondary beam, two-way slab with 2 secondary beam, or you can use one-way slab here. If you use here, you can change the load combination also. You can change all parameter in here. You can calculate this one. If you choose this option, again you calculate. If you show this one, if you choose the third option, calculate. If you show this one, for the fourth option, it will be this one. Now I choose the third option. I calculate here. If we okay with this value, click OK. You need to apply to the model also. Click Apply. For the second subgroup here, I don't want to use the tributary area load, but I want to directly modify something in here. Now I want the incline uniform shape of the load. Put 0 here, try to see. Okay, I would like to get this pattern of load. Apply. Now based on 2 subgroup of load, we'll get a new thing here, but it's still not assigned to perform yet. You also can change this all parameter, all value in Excel also. Just click here to Excel. It will show all element load name, element group, subgroup, and the load that you define. You can change the load in here and span as well. If you don't want to change anything, just from Excel. Load back. Now click OK. It's time to reopen. Perform again. Currently, you will see only the original one after you reopen. Perform. Go to see the same load case. Now you can see the new load pattern is already assigned to perform 3D. This is all of the modeling phase tutorial of PX program.